Now, for video 2, I'd like to talk about these MP Lab Express Evaluation boards that our microchip sponsor, Garrett, has given us. Now, we're going to be using these to test out our sensors and anything else that we're planning on putting on the node. Now, he did give us 4 of these, one for each of our group members, so each of us are going to split up and try out a separate sensor. He also gave us a clickboard which already has certain weather functionality in there, such as temperature, pressure, those kind of sensors. We will also be testing those that are already built in to see if perhaps that is a better route to go. Currently, I personally am going to be trying to do the temperature sensor. Now, this will involve multiple steps, but this is where I'm starting from for this week of work.
Some of the resources we are using to draw upon for examples on our final designs are mobile and desktop apps such as WeatherBug, a website called Weather Underground, and the Weather Channel application. Our application will have the same map conceptions, except with more information at specific locations that the user would like to see.
So speaking of applications, we've made our own with a cute little icon. When you open it up, you can get a fully interactive Google Maps. We did this by writing code in Java and using a Google Maps API key, which thankfully is free provided we do not access information multiple thousand times a day. Each of these markers represents where one of our nodes would be as far as location goes, but these 3 locations are just for testing. When selected, they display information as you can see on screen. This application will not actually directly interact with our nodes, but rather with the website which we will set up, and that website serves to aggregate the information dumped from our nodes. So essentially, this scans through the text of our website, knows where to look for temperature for the node in Scottsdale, and then puts that into a variable and then displays it to the screen. And that's about it.
I will now talk about our first expert interview with Jacob Dopkins, a systems engineer at Intel. The topics we discussed in this meeting include cloud computing and Internet of Things, LoRa technology, existing LoRa gateway products, and implementation of the LoRa end-to-end solution. One of the goals of this meeting was to understand how LoRa technology works with our product. We will be using Microchip's RN2483 module, which provides LoRa Wide Area Network Protocol connectivity using a simple UART interface. This module handles the LoRa Wide Area Network Class A protocol, which means that it has passed LoRa Alliance certification testing and can operate in the license-free ISM bands of 433 MHz and 868 MHz. This also means that our product is fully FCC verified. This frequency range is reserved for ISM bands which service industrial, scientific, and medical purposes only. This will hopefully help limit interference from other applications and radio communication. So the onboard LoRa Wide Area Network Protocol enables seamless connectivity to any LoRa compliant network infrastructure, which will be our LoRa gateway. The LoRa gateway can be easily set up with any device that has internet connectivity and can process data packets. As you can see here, the LoRa gateway will be connected to many nodes, which will be our weather station or RN2483 modules. The maximum distance between the node and the gateway has to be up to 15 kilometers. Each node containing a host MCU will read a sensor and command the RN2483 to transmit the sensor reading over the LoRa network. The data is then encrypted by the RN2483 and the radio packet is received by the gateway and is then forwarded to the network server, which will be a laptop or desktop computer. One of the limitations we will face is that the gateway can only service up to 1 node data packet request at a time. Something else we have to consider is what device we will use to set up our LoRa gateway. Jacob suggested we use a Raspberry Pi with a LoRa M card provided by Multitech. The Raspberry Pi can perform the data packet computations, and the LoRa M card provides the LoRa connectivity. This device will be easy to implement. However, one thing we have to consider is that the device with the Raspberry Pi and the LoRa M card will come out to about $200 per gateway. One of our next steps is to find a cheaper solution.